Hello everyone. Today we'll be going through AS A-level chemistry topic, and this topic is included in Cambridge, Edexcel, EQA, Oxford, and other boards as well. So it's comprehensive topic and disclaimer. And then topic is trends in ionization energy. And first of all, we'll go through ionization energy definition, what is ionization energy? The minimum amount of energy required to remove the valence electrons. So the outermost electrons you want to remove, that is the most loosely bounded electron from the from an isolated gaseous atom or ion. And it is in kilojoules per mole. We are taking kilojoules per mole. This one is basically the units which we are taking. Now, after defining ionization energy, we will come to discuss four factors that affect ionization energy. What are those four factors? First of them is nuclear charge. So higher the nuclear charge, protons are inside the nucleus and electrons are outside the nucleus, and higher the charge inside the nucleus will be affecting and pulling electrons with a higher force, and you require more ionization energy to remove outermost electron. So this one, in this case, higher protons will be pulling electrons with the higher force, and this will be requiring more energy to knock out electron from its outermost orbit. So second point we come to know is that distance from the nucleus. If distance will be more, then it will be easier to knock out that electron, because it will be under lesser influence of the nucleus. So lower an ionization energy if distance from the nucleus is higher. So we can see that in periodic chart, size of the atoms is increasing down the group, and this is why the ionization energy will be reducing down the group. And on the right side, from left to right, it is increasing because charge is increasing, but size is reducing. So electrons are coming under higher influence of the nucleus. So the next thing which is affecting ionization energy is shielding effect. And shielding effect is the hindrance faced by electrons when they are being attracted by the nucleus. So positive charge is attracting nucleus, whereas the same charges, electrons and electrons, are repelling each other. So this will be the force of attraction between the electron and the nucleus, whereas same electrons will be repelling each other, and this repulsion is known as shielding effect. So we say that electrons in the inner shells repel electrons in outer shells. More inner electron shells means greater shielding, and therefore a lower ionization energy. So this was the third factor. Fourth factor, if we go through, is spin pair repulsion. Spin pair, electrons are having a spin clockwise or anti-clockwise, and if both are there if we go through electronic distribution, if both electrons are there, then they will be having spin pair repulsion also. So more repulsion in two electrons as compared to one electron in an orbital. So lower ionization in case of two electrons in an orbital. So if orbital is completely filled, it means it will be having two electrons, which is one is having opposite spin to the other. So it will be easier to remove if orbital is containing two electrons as compared to one electron. Next thing, if we go through, is trends in ionization energy. If we go through the periodic chart, so from in case of group, ionization energy is, first ionization energy we are talking about is increasing from down to up, and from left to right also it is increasing. and increasing trend is also from left lower corner to upper right corner also. So these are the trends. If we go through the trends, first of all, ionization energies show periodicity. So it's a periodic change, recurring trends across each period of the periodic table. So they are recurring. And the second thing is, as you move left to right across a period, left to right across a period, which is this arrow is showing, first ionization energy generally increases, and next is the trend is linked to the electronic configuration of electrons. So electronic configuration is determining this one. And group 1 metals, like for example, if we take group 1 metals, which are lithium, sodium, potassium, rubidium, cesium, francium, and for example, sodium have low first ionization energies because they have a single outer electron that is easy to remove. We will discuss some anomalies also in next section. So noble gases, you know, is this last group, neon, argon, krypton, xenon. So noble gases have very high ionization energy because their outermost orbits are filled and they are under the influence of nucleus, and it's very difficult to remove electrons. Next thing, we will be going through ionization energy and the periodic table. We'll be going through the summary, and the summary we will be basing on this diagram. It will be better to understand this. So first of all, across the period, we will see across the period is ionization energy is increasing from left to right, and first ionization energy increases due to higher nuclear charge and same shielding. You should know the reasons also. Higher ionization energy is fine, but you will have to give the reason also why it is higher. And down the group is decreasing. Down the group is decreasing as the arrow is showing. So first ionization energy decreases, and reason is greater atomic radius and more shielding effect. So if we make a table comparison to summarize all these points, so across a period ionization energy increases, and down the group ionization energy decreases. This is the general thing, but we should know that increase in nuclear charge is across the period and increase in nuclear charge is down the group. Then the same number of shells remains same in a period, whereas in increased number of shells in case of groups. When group is, we are going down the group, number of shells are increasing. So distance from the outer electron to the nucleus decreases, and distance from the outer electron to the nucleus increases in case of group. So shielding remains relatively constant when we discuss period. So it remains relatively constant while the shielding increases down the group. So decrease in case of period, atomic size or radius is decreasing in case of atom, or ionic radius in case of ion, whereas down the group in radius of atom or ion will be increasing. The attraction between the outer electron and the nucleus gets stronger, so the outer electron is harder to remove in case of period. And in case of groups, it will be easier to remove, and because distance is increasing and the attraction between the outer electron and the nucleus gets weaker, so the outer electron is easier to remove. Next thing, we will be going through anomalous trends in ionization energy. There are some anomalous results also. If we see this one, this is from hydrogen to calcium. We have shown first ionization energies from hydrogen to calcium, kilojoules per mole, and this is basically electron distribution for nitrogen and oxygen. We are discussing this specific anomaly, and if we see nitrogen and oxygen, this one is in case of oxygen, it is lesser. Energy is first ionization energy is lesser as compared to nitrogen. Reason for this is irregularities in the first ionization energy trends. If we see the nitrogen electronic distribution, it is 1s2, 2s2 and 2p3. So all three sub shells or orbitals are having one each, and when we remove this last one and nitrogen ion is formed, so it's easier to remove from this last orbital. Now in case of oxygen, electron distribution is 1s2, 2s2, 2p4. So this is having two electrons. This orbital is having two electrons, so it is difficult to remove. When we change to oxygen ion plus ion, so this double electron is removed and all three are having 2p, so it will be easier to remove. In this case, in oxygen case, it will be easier to remove, but in case of nitrogen, we have to break the complete orbit, then only we will be able to remove. So this is basically difficult to remove in case of nitrogen. That's why we are having higher ionization energy in case of nitrogen, and it is easier to remove in case of oxygen because of 2px, and this one is having 2px is having two electrons, so we can easily remove because of opposite spin. So nitrogen oxygen is having lesser first ionization energy. So this is the anomaly which we discussed. And if we see the electronic distribution, in case of nitrogen, 1s2, 2s2, 2px1, 2py1 and 2pz1, whereas in oxygen it will be 1s2, 2s2, 2p2, 2px2 and 2py1 and 2pz1. So you can see this difference between nitrogen and oxygen, and this is the reason behind this. So the reason I have understood here is that there are two electrons in the 2px orbital of oxygen, and because of electron repulsion, it is easier to remove the electron from here as opposed to the 2px orbital of nitrogen, which had only one electron. So this was the whole topic we have covered for ESC level. Hopefully you understood. Don't forget to subscribe the channel and introduce this channel to your respective teachers, and recommend this channel to your friends and class fellows. Thank you very much for watching. Take care. Bye.